Hi. We're here to talk today about implementing an enterprise risk system using Geode as the underlying caching mechanism. And I'm required to put this up for a few seconds. Really, it's not too important in this case because I'm not going to be promising any product in this particular exercise. But if I do say anything about any product having any particular feature in the future, I'm lying. That's what this says. Okay, my name is Mike Stolz. I'm principal engineer for Pivotal, serving as product manager for Gemstone and Geode, Gemfire and Geode, I should say. I've been with the firm since about 2007. Prior to that, I was the first customer to use Geode, and that was at Merrill Lynch, where I used it to build currency trading, credit trading, and risk management systems for the fixed income and other areas of the bank. This is Andre Langevin.
Hello, good afternoon. So I don't actually work at Pivotal. The disclaimer was just for Mike. I've been working in the banking industry for about 15 years, building risk systems. I've worked at a few banks, a stock exchange, a pension fund. I think I've probably tried this from every angle. What's particularly interesting, and I'm honored here today to be talking with Mike, is that in my career I've actually built several very important risk systems for banks that are based on the work Mike did at Merrill Lynch originally. So Mike is actually a luminary in the risk systems business, in addition to being quite famous as the principal engineer for Geode. So I always feel like this is going to be anticlimactic, but bang!
There it is.
There it is. Big time Wall Street, all in one
and it
slide
works.
for you. So this is a simple high-level schematic of how we build most live risk systems for real-time trading of derivatives. Maybe I should pause here quickly. Mike and I were saying there's probably going to be 20 people here, and that looks about right. And we bet that all 20 of you are in the same business we are, that you're builders of risk systems or work on Wall Street. Is that fairly accurate? Okay, cool.
Wow, only 3? Really?
All right. So welcome to the tribe, for those of you who aren't. What's interesting about this particular piece of systems building is that it's pervasive. All of the banks that have this type of solution, all the trading floors, do it the same way with the same technology, with Apache Geode, Gemfire. There really isn't a lot of variation. But at the same time, this is also something that you can't just go buy a book and learn how to do. We've all learned this by working together over the years at different firms, which I think is fascinating. So you're all now, I guess, extensions of that small circle of people who know how to do this.
Tribal knowledge. Welcome to the tribe.
Yes, there are no tattoos. It's not painful to join. So let's talk a bit about what do we see behind us here. We're a trading floor, so obviously we trade things. We trade derivatives, we trade securities, foreign exchange, all of that good stuff. The trades in the diagram are our trades, the firm. The market data is from the broader market. That's things like securities prices, interest rates, foreign exchange quotations. These are the things that are the source of the risk that we're trying to manage. I'm sure all of you have bought a stock for your IRA or maybe your own trading account, and you're aware the price kind of bounces up and down and you might make or lose money. For a securities firm, this is a really big deal because they're doing it to scale. That market data is that driver. The gray box, risk calculations, is actually my favorite part of this solution. So big time trading floors employ teams of mathematicians, usually physicists, to create their very own pricing models. Physicists are not really fans of simplicity, so these things tend to be diabolically complicated, real masterpieces of calculus. And they take huge grids of computers to run. That's how we actually value the trades that we trade in our Wall Street firms. So we have this thing. We want to hook it up to the trade feed and the market data using Geode in order to produce that last colored box, risk. Interesting, I think. So let's back up for a sec and take a look at why are we building this thing. I think it's always critical to understand the business driver of the thing you're solving. Somebody did ask me, is Crash Course an unintentional joke? No, it's very intentional. I thought this would be funny. What's important to understand here is 15 years ago when I started in this business, trading was actually relatively straightforward. Traders traded a product, so I might be the bond trader or the FX trader or the equity trader, and they had one trading system, and they'd type all their trades in, and the trading system would tell them you made this much money today and you're taking roughly this much risk. Easy peasy, everybody got it. Over the 15 years, with the rise in derivatives and the increase in sophistication in the financial system, that has exploded. We have hundreds of products now that we trade. We often have 50 booking systems, so 50 different trading systems where we used to have one or two. And the way we look at risk has become very sophisticated. We look for all sorts of secondary and tertiary factors. Anybody that's a fan of calculus would love this business now. The upshot of this as a systems builder is that the one guy with the one screen is over. The business has reorganized itself by market and into teams of traders whose products fall within markets. So whatever firm you work at on Wall Street or Bay Street or in the city of London, I guarantee you that somewhere in your firm there is a group called FIC, Fixed Income Commodities and Currencies, that trades markets. So our solution is aimed at those people. Let's also take a second and talk about how are we calculating risk. Nobody here was a physicist, right? Excellent. They always hate when I do this because I'm going to wildly oversimplify all this to make for a really good speech. For today, let's forget about all the tertiary factors in risk and let's just talk about market risk. How much do you make or lose if the markets go up or down on all the things you're holding right now? Nice and simple. The solution that we're talking about works for all kinds of other fancy forms of risk, but this is the simplest and it makes for the, I think, nicest speech, so let's go with that, right? I am going quickly here, I should emphasize, because we only have half an hour. If anyone has questions at the end, we'll stay. I realize we're blowing through a lot of material here. So right after Crash Course, I have some awesome ideas that will totally not work that you could do instead of what we're proposing here. As an architect, sorry about that, I really love this slide, things that work badly. How do I know these work badly? I've seen people do each and every one of them several times. What's important here is if you think back to the good old days of just one or two or three systems, your first idea to get a consolidated picture of that might be to book trades from system A and B and from B and A so that the guys trading them get to see everything. Very reasonable. This happened quite a lot at the beginning of the explosion in products. The problem when you do this is that you have to undo it downstream in order to get a coherent picture of risk for the firm and to settle your trades and for clearing. So for every little bit of energy you save at the front end of this, you create a colossal waste of energy downstream. So don't do any of these things, please. And if your firm is doing these, stop it. Do the next part. So now we know what we're doing really quickly. Let's back up and look at how are we going to glue all of these things together using Geode in order to get our solution. Thank you, sir. So everybody who's ever worked on a trading floor knows that traders like Excel and traders have very short tempers. If you want traders to use your solution, what you need to do is make it intuitive and easy to use for a trader. So beyond all the great technology things we're going to tell you, I have this golden social engineering tip here for you that you can use, which is that given that Geode is basically a key value type of store, choose keys that the traders can guess. If you stop and think about that, that seems really obvious, and yet everybody looks astonished when I suggest this. Why would you want them to be able to guess that? Because, hey, they can hook up a spreadsheet to your Geode region and pull data out of it easily and intuitively. So this dot notation, which I think someone in Mike's team at Merrill probably invented, we all owe Mike a royalty payment on this, is the best way we've ever come up with to do this. So choose names like USD, LIBOR 3 months, USD, LIBOR 6 months, that people can guess.
And the beauty of this is that you don't ever need to do a query. You can get everything right from the key.
Yeah. All right. Let's also think a little bit about region design. So we're trying to compress a lot here into half an hour. There's a bunch of important items in your data model that you need to represent as regions. So your trades, obviously, your market data, obviously, the risk results you compute. You need to think about balancing the size of these regions with the speed of access. Because we like this thing to work at Wall Street speed, which is very close to real time, performance is critical. So you do need to think carefully about the trade-offs you're making. The best advice I have for you to build this, and I think this is the standard, is create a region for trades. If the way you're getting your trades includes all the model parameters that you use to price them, then perhaps you want to put those in a second region just to feed to your math library. Not a bad optimization. For your market data is a curve of securities. Separate those. The securities get updated a lot, the curves don't. That optimizes the access against the contention for the region. And also take your risk results, which are going to come streaming back from the compute side of this, and give them their own region as well. You might, if you're aggregating in Geode, create a second region with the aggregates as well. A lot there. You can ask questions at the end. The other thing you need to think about here is this is distributed over a cluster. How will I distribute the data to optimize the performance of this solution? The important thing is that every computation you're doing, and you're doing lots, requires a trade and some market data and maybe some other market data. So there's a collection of accesses to regions each time you push a trade through this solution or try to do evaluation. One of the great lessons of building risk systems is that it's often more effective to physically reorganize the way you're storing your data than it is to try to optimize the computation that consumes it. In this case, what that means is that you want to spread out some of the data, like the trades, in a way that you can spread the market data out to follow. So, for example, invent a partition key that applies to both equally. Some of the data you want to just replicate. Foreign exchange rates, for example, are very small. It's cheap. Splatter them on every single node in the grid so that you never have to worry about affinity with those.
Okay. So one of the things that's kind of interesting is that the models are almost always written in C++ or C#, and Gemfire and Geode are written in Java. So there's an impedance mismatch there. But there is a mechanism within Geode to handle that impedance mismatch, and it is called PDX, or Portable Data Exchange Wire Format. Funny thing, gotta tell a joke, PDX is also the initials for the Portland Airport, and that's where the Geode engineering team lives, is Portland. So that's part of how it got its name.
I don't think I knew that. I've been using this for 10 years.
Okay. Another nice thing about this PDX thing is that it deals with JSON natively. So JSON becomes a really nice format to use to push trades and stuff and market data and whatever else into Geode for subsequent consumption by the models. Not everything is going to be able to come in, though, in a nice simple format like that. You're going to get some things in like FPML format or something like that, and that's, you know, a big massive XML document. So I guess the bottom line is getting the data in is not a trivial task. You're going to have to do some manipulation of that data to get it in some kind of a consumable fashion. If you're really lucky, you might have your compute model actually know how to serialize itself and deserialize itself, but most places aren't that lucky. So you're probably going to have to do some sort of conversion from what the trading system has to what your arithmetic models want. that kind of calls for something external. You don't want to necessarily be doing that inside of the data grid. You probably want to be doing that outside. One tool that I think probably makes a lot of sense for doing that kind of stuff is something like Spring XD or Spring Cloud Data Flow. The whole notion of using the Spring integration capabilities can make this kind of stuff a whole lot easier. Okay, so once you've got the stuff converted and you're putting it in, you can't lose a trade. This is really critical information. This is stuff that if you lose one of these, that's not going to be good at all.
Yeah.
Okay, so you
That
definitely
creates cranky traders, and nobody likes cranky traders.
I've had more than one phone thrown at me in my life on the trading floor.
Yeah. That's something they don't tell you when you apply for this job, that you have to be able to dodge thrown objects fairly effectively to get to your 5-year pin.
Okay, getting market data in is also not simple. First of all, market data is wildly different in terms of how fast it comes at you. So you've got things like ticking FX rates. They tick really, really fast, hundreds of times per second maybe. At the same time, you have this thing called LIBOR that almost every trade is affected by and needs to use it in its calculation. That changes once every day. Exactly once, at a very set time of day. And so what you're going to really need to do is you're going to need to gate that incoming market data, that fast moving stuff, because what you really would like to do is have a consistent view of the market data for the duration of the risk run. So you kind of want to sort of stop the stuff from getting put into the calculation, sort of get a snapshot. There's some work we are doing in Geode to make it so that you can have multiple snapshots at any given time, and we're doing that based on some notion of a temporal storage and temporal indexing. But now I'm talking futures, so I'm lying to you. Okay, crunching the numbers. So after you get everything into Geode so that it's accessible, now you want to fire off a compute job. Most companies are using as their compute grid product something like Data Synapse or Platform Symphony, and there are a few others. And they pretty much all have a notion of a head node or a broker that is the thing that manages where compute is going to happen. The compute nodes pretty much use a pull semantic. They pull a task from the broker when they're ready. And then that task can have data associated with it, so it might, for instance, the task might have a trade associated with it. And then that trade has certain things that it's sensitive to, and usually the model figures out from the trade what market data I'm going to need in order to value this trade. That getting of the market data then can be a pull from the grid. So we push the trade to the broker, we pull the market data and anything else we need from the data grid, and then we go ahead and perform the calculation, and then we push the result, which is usually larger than the inputs by a significant amount, back out to the grid for aggregation.
But people also use Gemfire as a local cache in these compute grids. It's probably a longer topic, but...
Yep, absolutely. So there's something, so if in the client side, there is a thing called a caching proxy, which means if you've received this trade before, put it in this local cache, put the market data in the local cache. It's like all automatic, basically. It's all just done for you for free. And if you happen to get the same trade or need the same market data the next time around, you won't even make the round trip to the server. It's already in your memory. So that's the difference between 1 microsecond and 300 microseconds.
Which matters.
It matters when you're doing, a couple of billion calculations.
Darn right.
A thing I like to think about, though, and we actually had a third-party benchmarking company prove this for us, is that we can actually crunch inside of the fabric, inside of the data nodes themselves. And what I really mean there is, instead of pushing the data to the compute, we're pushing the compute to the data. And since you only push the compute, the jar file, once, and you're just executing it all the other times, this is a tremendous savings. So with the securities technology Analysis Center, STAC, is an organization that was created by Wall Street for Wall Street to do benchmarks that we can trust. And several years ago, they did a benchmark of exactly what I just described. They first went ahead and used a typical compute grid with a separate data grid. They pulled the data to the compute grid the way I described earlier, did the computations, pushed the results back. Then they turned off the compute grid, relocated the code that was doing the computation into the data grid, and redid the exact same test. And it ran 76 times faster, not 76% faster, 76 times faster. Why is that? Because we removed all of the network I/O.
Jim, if you think about it, to do a project like this at a major bank is $20 million roughly. Quarter of it is hardware. If you could actually implement it this way, think of the deflation you'd get on that $5 million hardware bill. That's a lot of bonus checks for the IT department.
Now, the downside is you've got to rewrite the models that were written in C++ in Java because Geode is Java. So that's the big trade-off that you're making in order to be able to do this.
That's very hard too. That's in fact impossible at a lot of the Wall Street firms. No bonuses for us.
Okay, and then there's the easy part of this. After you've done all the work and done the computation, put the results out, and done the aggregations and all that kind of stuff, this is the point at which you're going to do the aggregations and then display. It's what we'll call your ticking risk views. This is being able to see it somewhere, okay? Now, the kind of aggregation that we're going to be doing is things like aggregating by sector, aggregating by country. We may have country risk. Sometimes you're aggregating by corporation. There's lots of different things that we'll aggregate by. There are some pretty good products in the aggregation space. Armanta is very good, Ion is very good. There's one thing that's interesting about these products in that space is that they are not, at this point, natively integrated with Gemfire, but there is one of these products that is actually natively integrated with the Geode continuous query mechanism, and it's not mentioned here on this slide, but it is Active Pivot. That one is actually integrated. So what that'll give you is the ability to actually, with writing no additional code, just set up a where clause and tell it what books you're interested in displaying, and it'll give you exactly what you want. Okay. So that pretty much concludes what it is that we wanted to talk about. If you really want to dive deep into it, we wrote a white paper together, and you can get that. Well, I don't know how you're going to get. You can take a picture of the URL. I see lots of cameras popping up. Okay.
So if this was the best half hour of your week, this is the best 12 pages of your month.
And the other thing I would encourage is that you. If you're interested in Geode at all, you can learn a lot more about it. It's completely open. You can get on the user subscription list, mailing list. You can get on the dev mailing list too if you'd actually like to get even deeper involved in steering it or even contributing to it. There are a couple of Geode releases out already. Milestones 1 and 2 are done. Milestone 3 is just days away. There's a commercial product called Gemfire that we've mentioned once or twice here that is based 100% on the open source Geode bits. And with that, I'd like to encourage you to take a look at John Bloom and Luke Shannon's session on August 4th, 9 a.m. They're going to actually do a demo of using Geode for a real world sort of an application. That's right, Brian Dunlap from Southwest Airlines will be talking at 5, I believe, 5 p.m. today.
Yeah, I mean, not a risk guy, but very sophisticated user of the technology and a better speaker than I am. So, well, we're seeing. Yeah.
Yep.
Do you know what, we have a couple of minutes left. Would anyone like to ask a question? I'm
the product manager for both, and I can tell you that Geode 1.0, which is coming out very, very soon, and GemFire 9.0, which is coming out very shortly thereafter, are the same bits.
Okay, so and then the model, I guess, development would be what? Where will the features be added first?
Features are going to tend to be added to Geode first. In fact, there are some features that have already been contributed that are not going to make it into the actual mainstream release of either Geode or GemFire, but are there and available should you choose to include them.
You know, those are very good questions. Thank you. As a builder of this stuff on the bank side, one of the things that I think is great about Geode being open source is you can write your own code against the actual code base now. You know, in years past, you would be stuck trying to overlay it somehow, and it's never as good as actually weaving it through it. So definitely that, I think, is the best thing that's happened in this
Yeah, the
space in
community is
quite a while.
growing rather quickly now. It took a little while to get it bootstrapped, but it's growing nicely now. We're getting contributions. Whole features have been contributed that we didn't have any idea anybody even had percolating in their minds. So, very cool.
Cool. Others?
Sorry, I was lost again. Deployment, I remember, I mean, it's been a while, at least 4 years deploying GemFire. It's quite painful. Is there anything that, you know, would be improved in Geode 1.0?
So, yeah, so it's actually, we were already running on PCF in Azure in production today. And that's FordPass. FordPass uses Geode or GemFire as the system of record for all of the data that is in the FordPass mobile app. And they're public about it, so I'm allowed to say that in public.
I will say one of the things I'm so happy about having Mike here is those really tough questions I can just although those are questions as a practitioner I think I've hit as well.
And PCF on AWS also, we're not in production with anybody on that yet, but we will be very soon. And of course, vSphere and bare metal.
And OpenStack?
I don't think I've seen an OpenStack implementation yet.
Sure.
Actually, so the product manager for the GemFire on PCF is sitting in the back there, and he just shook his head no. Hi, William. How you doing?
In the presentation, you guys were comparing and contrasting connecting to a computational grid versus running the computations within Geode, and then you made a statement of this would shrink your hardware usage, and et cetera. The systems you worked on, did they actually integrate with the compute grid, or did you actually use Geode for computation, or are you just making if you were to do it today, suggestion?
So the question is, did we actually get to do the computation inside the data grid anywhere? And the answer is, I was lucky. I had an old enough set of models that I had to rewrite them. I could not port them. They were written in COBOL. So I actually got lucky. I got to rewrite all the models in Java, put them in GemFire, and run them right there in situ.
Yeah, I've never seen that, and all of the banks that I've worked at are very committed to their now C# models. It comes from, I guess, about 5 years ago when a lot of the capital markets business moved off Solaris. They wanted to all start using Intel hardware to get better floating point math, and so everybody rewrote all the C++ into C#. That's a very hard thing to reverse at this point.
Yeah.
I think one thing that's interesting is that, especially with this being Geode now open sourced, it democratizes the solution a little. There's no reason why, if you're a regional bank or a pension fund or an insurance company, that you can't take an off-the-shelf math library like Numerics or FinCAD and actually implement this in Geode as a smaller, more effective solution. I know of at least one insurance company in Canada that's actually done that. So.
Okay, I'm being told that we're out of time.
Red card. Uh-oh.
Yep, we've been red carded. So
Thank you so much
we'll
for your
hang
time.
around, take any questions.